Good afternoon everyone and welcome to the session. Today we are going to deal with divide and conquer strategy. During last class we have given an outline on dynamic programming which comes in your fourth module. We have covered optimality principle, optimal matrix multiplication, Bell-Manford algorithm and the basic analysis. Today we are going to cover divide and conquer, the two-way merge sort, Stresenc's multiplication, its analysis, and also a bit of fifth module, the comparison of divide and conquer with dynamic programming. So these are the items that we are going to discuss today. So let's start with divide and conquer strategy. As dynamic programming was a algorithm design strategy, divide and conquer is also a strategy that is used to solve problems. We know that we have different algorithm solving strategies like branch and bound, backtracking, etc. We, as a computer engineer or as a student who is studying algorithms, we should be very much careful, or we should be keen where to use which strategy. Okay, we will be seeing that in the later half of the session. So how divide and conquer strategy works? It is a basic strategy that we always adopt whenever we are having some real life problems. What we do, we break down the problem into two or more sub problems of the same type or the related type, and then we will find solutions to those sub problems and they combine together so that it gives the solution of the original problem. This is what a divide and conquer strategy works on, which means that I am given a particular task to say multiply 100 numbers. Okay, what will I do? I will find 10 friends. I will give first 10 numbers to one of my friend and tell him to multiply it for me. Give the next 10 numbers to other person, and so on. So finally, whenever I get the results, I need to do one more multiplication so that I get the total answer. Fine. So this is an example for divide and conquer strategy. So let me ask you a very simple question. You are going to organize a particular event in your college. Okay. It has a different subtasks, right? Starting from a program committee forming, we have to do another particular committee, they have to do these things, so and so on. Will this come under divide and conquer strategy? Because I am having a bigger problem of conducting an event. I have divided sub problems given into so many groups or committees, and they will be doing that particular task, and finally the program will be completed. Will this come under divide and conquer strategy? No, it will not. Why? Because all the sub problems should be of the same type. For example, if it is a sorting problem, all the sub problems of the sorting problem should also be a sorting problem. Then only we can say that it is a divide and conquer strategy. I think it is clear. Okay. So this technique basically contains three parts. First one is the divide part, conquer part, and the combination part. What is divide part? This actually divides the problem into different sub-problems. Like we said earlier, I was having a bigger problem. I divided into sub-problem and given to many functions in order to do it. Then the second part comes, that is conquer, which means the sub-problems by recursive call it is solved. Why we are telling it's a recursive call? Because we told that if we are doing a sorting function, all the sub function will also be a sort. So we can just write the function one time and we can recursively call so that the program will be solved. The third is combine, which means that the sub problems are now being solved, right? We need to combine the solutions of the sub problems so that we get the final solution. This is the combine or combination part. So divide and conquer can be divided into basically three methods. First one is called division, second one is conquer, and third one is the combine. So all these three come togetherly forms the basic steps in divide and conquer. Clear? So this is a diagrammatic representation of divide and conquer. you have a central problem that is divided into subproblems. The subproblems were easily able to be divided into further subproblems. So we are dividing it again and we are finding the solutions to subproblems. Whenever we get the solutions to subproblems, we will be combining it so that the subproblem solutions are combined and finally we get the solution to our main problem. So this is how we diagrammatically represent divide and conquer strategy. Next comes the control abstraction. What do you mean by control abstraction? It basically represents or shows how a particular process works, which means that everyone, we know how to play cricket, right? Okay, what is the control abstraction of cricket? Okay, 11 players in one side, 11 players in other side. We'll be having a batsman, we'll be having a bowler. The batsman bats, gets runs, bowler bowls. If he gets wicket, he's out. So it is a set of procedures. It's not the algorithm, right? It is not an algorithm. It's a set of procedures that is basically needed in order to finish a task. So that is called a control abstraction. So how can you say the control abstraction of divide and conquer? Okay, so just see that. D and C stands for divide and conquer and P stands for the problem. If small p, which means that if the problem is very small, then return S of p. If the problem is very small and if I know the solution, you can return the solution. Okay, that is S of p. Else, divide the problem P into smaller problems, P1, P2, etc. up to Pk. And apply divide and conquer to each of these subproblems. That is a recursive call. And combine the solutions of divide and conquer of P1, P2, etc. up to P, so that you get the solution of the entire problem. So this is the control abstraction of divide and conquer strategy. Okay. So now we can see some of the algorithms or some basic problems which can be solved using the concept of divide and conquer. Okay, first one is merge sorting. So before going to merge sort, let's start with a basic idea. What is merging? So merging is the process of combining two sorted list or array or linked list, anything. Okay, so for easiness I am using the term list over here. You can use array. The process of combining two sorted array into a single sorted array or list, which means that I am having a basic array having 10 elements and another array having 10 elements. Both array are being sorted. I need to combine these two and to form a single sorted list. For example, look, I am having a list A which contains the elements 2, 8, 15, 18 and a list B which contains 5, 9, 12 and 7. Now I need to find a new list C which should be a sorted list from A and B. So how will I start? So in order to start, I need to have some pointers or some variables pointing to the position, right? For example, I points to the elements in the list A, J points to the elements in the list B, and K points to the elements in the list C. Okay. So first thing about I will be looking is to compare AI with BJ. If AI is less than BJ, then copy AI to CK, else copy BJ. What do you mean? What is A of I? A of I is 2 and B of J is 5. I need to check if A of I less than B of J. That is 2 is less than 5. Yes, true, it's true. So what I need to do? I need to copy A of I, that is 2, to C of K. Okay, so I am copying which element? 2 to C of K. Clear? So 2 has been copied. So once this is copied, what should I do? Now increment the position K and position I or J depending which element is copied. So as I have copied I, the I position should be incremented. Similarly, K position should also be incremented. So I is now incremented and K is now incremented. Clear? So this is the first step. Again, I need to do the same merging process. Compare AI with BJ and do the same process. So now which all the items which I am comparing? 8 and 5. So 8 and 5, when I looked at AI less than BJ, which is 8 less than 5. 8 is less than 5? No, right? So then what should I do? Copy B of J, which means that 5 is being copied to C. 5 is being copied. Now what should I do? Now I should increment K and the position of I or J, depending which element is copied. So element copied is 5. So that is J. So J need to be incremented and K need to be incremented. Clear? Again, this process should do comparing AI and BJ. So now 8 is smaller, so 8 goes to C. Okay, I need to be incremented and K is incremented. Again, 15 and 9 is being compared. 9 is smaller, so 9 is being written and J and K is incremented. Now 15 and 12. Okay, so 12 is smaller. So 12 need to be copied over there and J need to be incremented and K need to be incremented. Okay, this process is continued until all the elements in the list are listed. Clear? So what happens if one list is completely finished? For example, my A list has been completely finished, but B is having some more elements. Should I do any more comparisons? No. Why? Because the B is already sorted and A is already completed. So I can just copy the remaining items in B to C. Clear? So this is the process of merging. Okay. So merging will come as a subfunction while we study merge sort. So understand the concept of merging now itself. Okay. So this is how merging takes place. So let's write the algorithm for merge sort or merging. So for merging, I need to have the two arrays or two lists A and B. Now I also need to know the length. So let the length of A be M and length of B be N. Okay. So first step was I was to initialize I, J and K. So let I equal to 1, J equal to 1 and K equal to 1. And what were we doing? We were comparing AI with BJ, and if it is smaller, we will be copying AI to CK and increment I and K. Else, what we used to copy? We used to copy BJ and increment J and K. Clear? How long did we do this? Until we reach the end of the list, right? Which means that while I equal to is less than or equal to M and J less than or equal to N, we have to do this process. So again we had a particular situation, right? What happens if one list gets exhausted earlier? If so, we need to copy the remaining elements to C. So I am writing a for loop. For I am not initializing I, because wherever is the position of the I, from there itself I need to copy. So for I less than the end of A, I plus plus, I need to copy the remaining elements to C, K. Else, if it was B is remaining, I need to do for the B. Clear? This is the merging procedure. I hope it is clear. So we started with A, B, length MN. We have initialized the values, and until we reach the end of the list, we have to compare and we have to increment. Okay, after that, whatever things are remaining, we have to copy it simply to the C array. Clear? Fine. So this is about one list. Okay, one list being merged. What if there are more than two lists? Okay, we had more than two lists. So we used two lists now. What if there is more than two lists? For example, I have four lists A, B, C and D. How will we do the comparison? So let L be the list, final list that we are having. Okay, so we have A, B, C and D, and L is the final list. So process is the same. We have to compare all the first elements, which means 4 in A, 3 in B, 8 in C and 2 in D. And we have to compare which one is smaller. Which is smaller? 2 is smaller, right? So 2 goes to the list and the pointer to 2 will be incremented, so that 2 goes, the pointer now points to 4. Now it again compares which of the element is smaller. Okay, so we again have 3 is the smallest element. So what can we do? 3 can be given to the list. So 3 is being written and the pointer of 3 goes down, which is now it is pointing 5. So now I have 4 in A, 5 in B, 8 in C and 4 in D. So 4 in A being the first position, we have 2, 4, but 4 in A is in the topmost priority position. So that 4 will be written and that position will be going down to 6. Again 6, 5, 8 and 4, which is smaller. 4 is smaller. So 4 again got written over there and the pointer is incremented to 18. Okay. This process is continued. Now next smaller value is 5. 5 is being written over there. The pointer is incremented to 6, 9, 8 and 18. 6 is the smallest value. 6 is being written over there. And 6 pointer is now pointing on 12. Next value is 8. The pointer is moved to 10. Then it is 9. This process is continued until all the elements are being listed in the final list. Okay. So how many lists have been merged? A is the first one, B is second list, 3 C and D is the fourth list. So we have merged 4 lists. That's why this is called 4-way merging. Okay. So 4-way merging means we merged 4 different lists. So coming to 2-way merge sort or 2-way merging. So what will be 2-way merging? It is the process by which we merge 2 lists at a particular time. So consider the same example A, B, C and D. Here we can do this process different ways. First we will be merging A and B. Okay, that will be 3, 4, 5, 6, 9 and 12. 3, 4, 5, 6, 9 and 12. Then we will be merging C and D. That will be 2, 4, 8, 10, 16 and 18. Again we have 2 lists E and F. So E and F will be merged and will be getting the C, that is 2, 3, 4, 4, 5, 6, 8, 9, 10, 12, 16 and 18. This is a 2-way merge sort. That is, we had 4 lists, we have taken 2 lists at a time and we have merged it. Okay. I can do the same process in a different manner. I will be merging A and B to form E. To that E, I will be sorting with C. To the result, I will be sorting with G. So in any manner, I can do the process. 2-way merge sort, how it is different from merge sort. So we will discuss that when we discuss merge sort. But we have to just see how it is different from 2-way merge sort. 2-way merge sort is an iterative process. That is a repeating procedure and it may normally make use of loops. We have seen now, right? But merge sort is a recursive procedure. So one is an iterative procedure using loop and merge sort is a recursive procedure because merge sort does the same stuff again and again by divide and conquer method. So the same function will be called again and again. So it's a recursive process. In 2-way merge sort, as we told that 2 lists are taken at a time and is merged. So consider we have 9, 3, 7, 5, 6, 4, 8, 2 as a list. We are taking 2 lists, that is 9 and 3 is taken and it is being merged, it is being arranged. Again 7 and 5 it is taken and it is being sorted. 6 and 4 being sorted to 4 and 6, 8 and 2 sorted at 2 and 8. Now we take 3, 9, 5 and 7. So this is the pass 1. Pass 2 we take 3, 5, 7 and 9 and 2, 4, 6 and 8. That is the pass 2. Again we will be going for one more pass which gives us the final result which is the pass 3. So this is how a 2-way merge sort actually happens. After knowing how a 2-way merge sort works, we need to check on how what is the complexity of the algorithm. So how much work is actually done in each pass? In the example we had 8 elements and it is being merged 3 times. Okay. we have 8 elements and it is being merged 3 times. Okay, you can see. So we can generalize that number of pass is equal to log n to the base 2. That is log 8 to the base 2, which is equal to 3. So also we are having n is the total number of elements and log n is the total number of passes. So the total complexity is equal to total number of elements into the passes, which comes to n log n. So that is the complexity of the algorithm. Okay. So after seeing two-way merge sort, let's see what is merge sort. We can see how it works or how it is different. We are taking the same example. Here we apply the straight down approach of divide and conquer strategy. So divide and conquer strategy, what does it say? We have to divide the problem into smaller problems. But what is a small problem? In the case of sorting, a small problem can be defined as a list having a single element. What do you mean by a list with a single element? If the list is having only one element, that means the list is being sorted. So we consider each element in the list as another list. So that's how the merge sort works. That is array with a single element. So in the case of merge sort, let's write down the algorithm first. How does merge sort work? So for merge sort, we need to have two pointers. That is the pointer which points to 9 and pointer which points to 2. That is the first element and last element. So let it be L and H. So first, after initializing L and H, we need to check how many elements are there. We need to check whether it's a small problem or a big problem. For that, I am checking if L less than 5. What is L less than 5? I am checking whether the element or the list contains only one element. If the list contains only one element, which means that this list is a simple list and it's a sorted list. We don't need to do anything. If L is less than H, it means that there is more than one element. So if L is less than H, we have to find out the middle position of the array by adding L plus H by 2. What is L plus H by 2? It is not 9 and 2. It is the index of the array. So 9 resides in the index position 0 and 2 resides in the index position, say how many number? 1, 2, 3, 4, 5, 6, 7, 8, 8. So 8 minus 1, 7. So 0 plus 7 by 2. That is 3. So 1, 2, 3. So mid position is 3. That is 4. So now what I need to do? I need to merge sort. It's a recursive procedure, right? What I need to sort? I need to sort from L to mid. That is the elements between 9 and 5 I need to sort. After that, what I need to do? I need to sort from mid plus 1 to H. That is from 6 to 2. Clear? So I am merging two elements, which means I am sorting the two elements. After sorting, what should I do? I need to combine it or merge it. So merge the L value, the lowest value, mid value and high value I need to merge. How do you merge? Using the merging function that we have already studied. Using that particular algorithm, we will be merging. So this is the process by which merge sort actually works. So let's see how this particular example works. So after finding mid, we will be splitting data from L to mid, that is 9, 3, 7 and 5, and we will be splitting the other half also 6, 4, 8 and 2, okay, into 2 and 2. Once it is divided into 2 and 2, it will be further divided into single elements 9, 3, 7, 5, 6, 4, 8 and 2. Now it's a smaller problem, right? That is only one element in the array, which is a smaller problem. Once it is a smaller problem, we need to combine. So 9 and 3, we have to sort it. So it is 3 and 9 when it is combined. 7 and 5, it is 5 and 7. Again 4 and 6 and 2 and 8. Now we are having sorted list of 2 elements. So we can again combine the 2 to form the 4 elements. So 3, 5, 7 and 9, 2, 4, 6 and 8. So we are having 2 different arrays. Now I need to combine it one more time. 2, 3, 4, 5, 6, 7, 8. So this is how merge sort basically works. So this is a divide and conquer strategy. I had a bigger problem. I divided the problem into sub-problems. The sub-problems again into sub-problems, found out the solution when the problem was small, combined the solution, and finally got the final answer. This is how merge sort works. So in our example, there were 8 elements and they were getting merged 3 times. So generalizing, we can say that n elements are getting merged log n times. So total complexity will be order of n log n. Okay. So we can represent it using the recurrence relation 2t n by 2 plus n for the merge sort. Why it is n by 2? Because we are taking the half, right? So 2t n by 2, 2 times plus n. So using Master's theorem, we can say that a equal to 2, b equal to n, f of n is equal to n, k is equal to 1. So this is the case 2, which comes into order of n log n. Clear? So this is the same time complexity. So this is about merge sorting and two-way merge sort. Okay, so it was working in the time complexity of n log. We can check out one more example, that is the matrix multiplication. It also follows the divide and conquer strategy. Consider I am having a array A which is having the elements A11, A12, A21 and A22 of the order 2 by 2, and B matrix B11, B12, B21 and B22 with the order 2 by 2. So when you multiply, we have to check the column of the first element, first array, and the row of the second array. They should be same, then only we can multiply. So when you multiply, the dimension of the final matrix that you get will be row of the first and column of the second matrix. That is equal to 2 by 2 matrix of C11, C12, C21 and C22. So now, how do you find the final element in C11, C12, C21 and C22? We can write a general equation. Cij equal to sigma k equal to 1 to n. N means column of first. Okay, that is 2. Aik into bkj. Okay, using this equation, we can get the formula for finding all the 4 elements in the resultant matrix. That is C11, which is equal to A11 into B11 plus A12 into B21. The normal matrix multiplication that we use. Similarly, you can write C12, C21 and C22. Okay, so here we have done nothing, the normal formulas of matrix multiplication. Okay, so let's write the basic algorithm or pseudocode that we used to do whenever we do the matrix multiplication. We normally used to have 3 for loops, a I loop, j loop and a k loop, and we finally do the matrix multiplication, right? So what is the time complexity of this? We are having 3 loops, okay, which means that order of n cube. Okay, so normal matrix multiplication works in order of n cube. Clear? So let's see what are the differences that we have when we go to divide and conquer strategy and stress and multiplication. Okay, so we are applying divide and conquer strategy to the matrix multiplication. So here I have the elements array. Oh, I have missed A. So A equal to A11, A12, A21, A22, B equal to and C equal to. Okay. So what is divide and conquer strategy? Divide and conquer strategy means we need to divide the problem into sub-problems. Okay, sub-problems which are small. So by mentioning small, what is the size that we are looking? We are looking for metrics which are having size less than 2 into 2. Okay. So what happens if we are having matrix of larger size? Then we have to split the matrix in order to make it 2 into 2 or less than 2 into 2. Okay, so let's see how the process works. Okay, so consider A and B as 2 matrices, which is a 4 into 4 matrix. So first thing that we need to do is we need to divide the bigger problem into smaller problem. By smaller problem, we understand that in the case of matrix multiplication, it is matrices with the order 2 into 2. So I am splitting the particular matrix. Okay, both matrix I am splitting, and now I am giving A11, A12, A21, and A22 to the 4 different parts. Now actually A11 contains element A11, A12, A21, and A22, but let A11 represents as a single element. Okay, A12 be another single element. Okay, so I had a bigger matrix, I divided it, okay, and I gave values. So similarly I did the same to B also. So now what happened? A is a 2 by 2 matrix of elements A, capital A11, capital A12, capital A21, and capital A22. So it's a 2 by 2 matrix. Clear? Similarly B. So I have divided the bigger problem into smaller problem. Okay. So now what should I do? So now I am going to write a matrix algorithm for matrix multiplication. Let A and B be the matrices and n be the size. So if n is less than 2, or if there are only 2 elements, I know that what should I do? Okay, 2 elements, 2 by 2 matrix, I know what should I do. I need to simply multiply, okay, using the formula that we have studied. Else what should I do? Else I should do divide the matrix to become small. So I have divided the matrix, and now I need to recursively call the particular function so that we get solution to the subproblem. So I am recursively calling A11, B11, and with the size n by 2, plus A12 and B21 with size n by 2. It is the same way that how we multiplied in matrix. Similarly, I need to do for all the 4 steps. Clear? If I do this, I will be getting the basic algorithm for matrix multiplication. Let's see what is the time complexity of this particular algorithm. The recurrence relation of this particular, sorry, the slide got fixed. I'm sorry. The slide just got skipped. So recurrence relation of this can be obtained as a t n by 2 plus n square. Using Master's theorem, we can solve a equal to 8, b equal to 2, and function is equal to n square, which means that time complexity is in the order of n cube. So using normal matrix multiplication, we got the order as order of n cube. Using divide and conquer, I got order as n cube. So time complexity, there is no much improvement. What about the space complexity? In the case of a normal matrix multiplication, I just need to have 3 loops. Here I need to have loops. I need to have more structures to store data. Or space complexity also, divide and conquer doesn't contribute much. Okay, so it's still an open question for students who are interested how to reduce the time complexity of matrix multiplication from order of n cube. So Stressen was a scientist who actually thought of how to reduce the complexity from order of n cube. And he has came with an interesting proposal of reducing the complexity. How to reduce the complexity? By reducing the number of multiplications. He came up with a solution like this. If you can find out P, Q, R, S, T, U, V, then you can find out the term C11, C12, C21, and C22 using these particular formulas. So what is the advantage of this? In normal multiplication, okay, in normal matrix multiplication, we actually had 8 different multiplications. A11 into B11, A12 into B21. We had 8 matrix multiplication. But in here we only have 7 multiplication. That is, the Streisand have decreased the number of multiplication by 1. But yes, it's true that the number of additions are increased, number of subtractions are increased. But whenever we think about the complexity, it's all about number of multiplications, because that's the one which give more time. Okay, so he had reduced the number of multiplications from 8 to 7. So the recurrence relation can be obtained as T of n equal to 1 when n less than equal to and 7T n by 2 plus n square when n is given. So by Master's theorem, when you solve this, you can get that complexity is in the order of n power 2.81. That is, the complexity has been decreased from order of n cube to order of n power 2.81, which means the complexity has been reduced slightly, but still it's a reduction, right? So Streisand's multiplication actually reduces the time complexity. So what about the space complexity? Space complexity, yes, we need to have extra pointers to store items, so space complexity is increased. So we can see an example also over here. So we are just writing what are A1, A2, A3, A12, B12, B11, etc. You are finding P, Q, R, S, T, U and V, and you are finding C11, C12, C21 and C22 directly from the formula, and you are finding the final answer. So that's about Streisand's multiplication. So this is the last, we are coming to the end of the session. What is the difference between dynamic programming and divide and conquer? So dynamic programming basically have a structure we use to find out the optimal solution from the list of solutions. It's a non-recursive and it solves the subproblem only once and stores in the table. It's a bottom-up approach and the subproblems are interdependent. But in case of divide and conquer, we have 3 steps: divide, conquer and combine. It's a recursive process. It does more work on the subproblem and hence it takes more time. It's actually a top-down design process and the subproblems are basically independent of each other. So this is the basic difference between dynamic programming and divide and conquer. So that's all for the session today. So I think you might have got an idea about how to work on how to start studying your portions on dynamic programming and divide and conquer. Hope the session helped you. Thank you for your patient listening. Stay at home and stay safe.